So I hope you all can see my screen now, right? I have started recording session and starting same topic, subnetting. And quickly, let me go through the next one. Yeah, like we finished question number 4. Yeah, okay. All right, so question number 5. Question number 5 here is like, which of the networks in the diagram could use a /29 mask? So basically, it's asking like if the mask is /29, so like how many hosts would be like in that specific subnet? So if mask /29 is used, so will there be like minimum 7 IPs in that subnet, 15 IPs, 13 IPs, 7 IPs, or 16 IPs? But question is like which of the networks here means like subnet or subnets in the diagram could use /29 mask. So like there are different options here, and if we look at different options, so A, B, C, D, E. So A is like corporate networks, means this one. B is like LA, SF, NY, and none. And the A one is corporate. So what do you think? Like which should be the correct answer? Like if mask is /29 mask, so how many valid IPs would be there in that subnet? I mean, like minimum 7 IPs or not, or 15 or 13. Like, I mean, like which option is correct? So what do you think? Like how many IPs in this subnet?
Are we looking for usable IP address or just IP address?
Usable IPs always like because and let me mention another important point here. I just remember that also. So in networking, like what we are doing, whenever we compute number of usable IPs, so we always subtract usable IPs. So we always subtract 2 IPs from the range, and you know the reason, because the first IP reserved and known as network or subnet address, and the last address is again reserved and internally used as a broadcast address. So whenever we compute number of IPs, then we always subtract 2 IPs. There is one exception to this rule, and exception is like when we do networking, the same networking in cloud, right? Cloud means like public cloud, like we have AWS public cloud, we have Microsoft Azure or Azure cloud, we have Google cloud. They all are like leading providers, and even like plenty of like other providers are there. So in cloud, whenever we use the same concept of like network, subnet, right? I mean, like we create a network, then in that network, we create different subnets, exactly the same way as we have been doing here. But in cloud, in fact, to find out usable IPs, we subtract total first IP, like whatever the first IP is. Like let's say if I take this example, maybe 192.168. So first IP is reserved, last IP reserved, very much same as we do in this networking. But apart from these two IPs, the very first IP after that means like the second IP is also reserved, and generally it is used as internal gateway address. Next to it, internal DNS address, another one for future use. So in cloud, whenever we compute number of valid IPs, then we subtract 5 IPs. We leave 5 IPs behind. 5 IPs, right? So there, if we are using /24 CIDR block in cloud, so in this network, physical network, right, the networking that we do, how do we calculate? So we compute number of hosts, right, number of host bits minus 2. And that comes to 254, and 2 we subtract because first and the last IPs both are reserved, cannot be assigned to any computer. If the same, you have been asked to compute number of valid IPs in cloud, maybe AWS cloud, right? So there, what we do, we subtract 5 IPs. Yes, correct. 5 IPs, because in cloud, in fact, 3 additional IPs are used internally by the cloud computing provider. This is like an exception to the rule, right? And but only for the cloud, in fact, right? Not in physical network. In physical networking, we always exclude 2 IPs only, first and the last. But this is one exception, that in cloud computing, whenever we compute number of usable IPs, we always subtract 5 IPs. 5 IPs are reserved, not only 2 IPs. So you'll have to keep that in mind if you are working uh, in cloud. I mean, like you are doing networking kind of stuff in cloud, AWS or Azure, later on, maybe anytime, whenever. So yes, like there, you subtract 5 IPs, but here, yes, only 2 IPs need to be subtracted. Yes, I'm giving record permission. Just give me a sec. Okay. So yeah, given. Okay, you can start recording now. So yes, like the question, like yes, like whether we will have to find out IPs, like the valid IPs. Yes, like valid IPs, usable IP, but keeping in mind like that your requirement is like 5 subnet, like one subnet here I can see, second subnet, maybe third subnet, or fourth, or maybe fifth. But here in this subnet, 7 users, here minimum 15, 13 minimum, 7 minimum, 16 users. So question is like, if we use /29 mask, so will the number of hosts can be accumulated anywhere, like can fit anywhere? I mean, like, can we do addressing in any subnet if we are using /29?
No.
So was no. Okay.
Yeah, because we
Mhm.
have 3 hosts, host to be,
Yes, host bits is equal to 3, correct?
and then to the power of 3
Okay.
is 8
8. Mm-hmm.
minus 2,
Correct.
6,
6.
and then
Exactly. And here, like the minimum number of the smallest subnet that I can see here, like 2 subnets, like corporate and NY, but it's still minimum 7 usable IPs. 7 usable IPs needed. And yes, if we are doing subnetting this way with /29 mask, so maximum there would be 6 usable IPs. So yes, like not like will not fit any subnet, in fact. So probably we have option here, none, I think. Let's say yes. So yes, the answer is correct, none. Answer E means like we cannot use /29 mask, in fact, not in any subnet. All right, and answer this question now. You have a class B network and need 29 subnets. 29 subnets needed. So what is your mask? I mean, like, and in class B, you must remember, it's a class B subnet now. Class B, like you can take any example, any IP address from the class B. So yes, it is class B, because if the first octet has any number between 128 to 191, the first octet, then it's always class B address. And in class B, by default, 16 bits network ID. So this initial 16 bits by default network bits by default, and rest 2 by default host bits. Means in class B, by default, the mask is /16. Now the question here, if you are asked to divide this class B network, this is class B network, You have been asked to divide this class B network in minimum 29 subnets, right? Minimum 29. Can be 30, 31, 32, no problem, but minimum 29 subnets. So what would be then subnet mask, right? So it's again an indirect question. Like, it's not asking directly. I mean, like, you'll have to find out borrowed bits and all that stuff, so that you can compute subnet mask. And the requirement is 29 subnets. So what? Just I'm taking a pause for a minute and just do your computation. And you have the requirement here: 29 subnets in class B, and it's a class B network. So default is 16 network bits. We have 16 bits for the host. Requirement is like 29 subnets. So what would be the mask? Do your computation and answer me in a minute or so.
So it is 255.255.255.248.
So your answer is 255.248.0. So, and
No,
what would be CIDR notation, CIDR notation? Like, if I'll have to write down in this format, so how many, what value I should write here?
no, I said 255, 255, 255, and 248, not 0. And then the CIDR will be 29.
CIDR will be 29. No, something wrong.
Okay.
Do your computation again.
Okay.
About the CIDR block, because if this is the mask like 255, 255, 248, so if the subnet mask need to be represented in this notation, CIDR notation, so what would be the CIDR notation? Anyone, like, just do your computation. What would be this? 29, like, uh, not correct, in fact. 29, because requirement is 29 subnets, that's correct. Like, this class B network has to be divided into 29 subnets. And if you do that, then the our answer is simply like the mask. In fact, this, what is the subnet mask? And I'm just looking for this question number 6 answer. So CIDR, do you remember like how we like write CIDR notation or CIDR block? In fact,
25
sorry,
/25.
25. You say?
Yeah.
No,
No.
16/16.
16 is the default, right? Without subnetting. But if you have already borrowed bits from the network portion, I already subnetted, then definitely would be greater than 16.
9.
So you're saying like 9 bits need to be borrowed, right?
Yeah. No,
So
I borrowed. Hold on, give me a second. Let me do it again. Sorry about that.
Yes, because there is some confusion. Just try to do it again.
Are we going to borrow 13? 13?
So just give me answer step by step. First answer, just find out like the number of bits that need to be borrowed from the subnet. So and question is like question number 6. Question is like, there is class B network. Network address is 172.16.0.0. If I write down mask this, then means /16. Or if I write down mask in decimal, then this is this. Right. Either way, like, you can write down in any way, or maybe you can write down like this: 33628 and then 33628. Anyway, now the question is, this is the network address given. For example, this is a class B network, and you have been asked to divide this network into minimum 29 subnets. So first question is like, determine number of bits that need to be borrowed, that need to be taken from host portion. How many bits you need to borrow in order to meet the objective? Objective is 29 subnets, right? So first question, like, so answer first question first, and then I'll break it down into different questions. So just calculate this only first. Number of bits that need to be borrowed from the host portion in order to have 29 subnets. in major network? That's first part of the question. So how many bits we need to borrow?
Over.
I'll say, one second. I'll say 13.
How many bits?
13.
13 bits. No, like there's something wrong, because if you borrow 13 bits, even we have option to borrow, because total, if like I write down in binary representation, so let me rub it. So /16 means like this is the default. So if I write down mask like this, means by default, forget about the subnetting. Without subnetting, the default mask /16 means 16 ones, 16 bits represent network portion, 16 ones, and then 16 zeros. 16 zeros because it's a class B network. 16 zeros means 16 host bits and 16 network bits default without doing subnetting. So without doing subnetting, 16 ones means like 16 network bits and 16 zeros means 16 host bits. So the first question, the first part of the question is, how many bits do we have to borrow from the host portion in order to divide a network into 29 subnets? That's the very first question, or first part of the question. So in order to have 29 subnets in this network, class B network, if you borrow, let's say, 1 bit, only 1 bit, for example, if you like, I mean, if I write down here number of bits borrowed, and here a table number of subnets, right? So if you borrow, let's say, 1 bit only, so this implies that total number of subnets will be 2. If we borrow 2 bits, then total number of subnets equal to 4. 3 bits, total number of subnets 8. If we borrow 4 bits, then total number of subnets 16. 5 bits, then 32. And we need to stop here, right?
Yeah,
5
5.
bits.
Yeah.
Because 32, right? We cannot get exact 29. So
Oh, okay.
even initially you done something 5 was something correct, but like the mask like and the cider block was something wrong. So let me get to that point also. So now decided what we will have to borrow 5 bits in order to get, or in order to logically divide a network into 32 subnets. Requirement is 29 even, but no problem, we cannot get exact 29. So one has to be near to that figure, and higher side, not lower side, in fact. So decided now that we are going to borrow 5 bits from the host portion. So remaining bits, still they are host bits, but 5 bits, borrowed bits, need to be converted in ones. So again, 5 ones here, 3 zeros remaining, and then 8 zeros remaining here still. 3, 3, 6, 2, 8. And already 16 ones. 16 ones. Now count number of ones. How many ones you can count from here? Number of ones. What is the value now?
255, 255, and 248.
And in number of ones, like if I have to write down in this format, then what I should
number
write down?
of 16 plus 5 is 21.
Correct. So the actual value is slash 21. And if I have to write down in decimal, as the question was, so 255, and this need to
248.
be converted, yes, 248.0, because the position value is 1, 2, 4, 8, 16, 32, 64, and 128, right? Or simply
Yeah.
you can just write 255 and then 1 plus 2 plus 4, 7, subtract 7 from 255, again you will get 240. But either way, like do computation in either way, or just the way like as I demonstrated on that day, like cancel all the values above zeros and add value above ones. So that's another way. But yes, like answer is correct, 255.248.0 in binary. I mean, like in cider notation, 21 will be the mask here. Got it? Let me go to the next question. Read this question and try to answer me like what is the maximum number of IP addresses? Again, usable IP addresses, right? Whenever you see the question like maximum number of IPs, you should always understand it's asking about the usable IPs that can be assigned to host on a local subnet that uses this mask. So which answer you think like should be correct? A, B, C, D, E, F.
30. 30.
30, this one? D?
Yeah.
Okay, let me verify this. So it's 224 means like in binary, if I convert only this portion, so it's 128, 64, 192, 224, and then 5 zeros. Yes, so if the binary conversion of 224 is this, and this way 1, 2, 3, 4, 5, 5 host bits.
32.
So correct. Answer is correct because 2 raised to power 5 minus 2. So 32 minus 2, that is 30. That's correct. So answer D, absolutely right. Okay. And now this one a bit not tricky, but a lot of computation. So maybe we will have to take calculator as well. But anyway, let me read the question. So this question has two parts. If this is the subnet mask cider block, then question is like how many subnets and hosts would be there? So basically it's already subnetted address, and how I can confidently say that that address is already subnetted? Remember class B address, right? And how we can say like the IP address is from the class B, because just look at the first octet. First octet is 172. 172 means definitely class B. Without subnetting, if we do not do subnetting, then class B network means only 16 bits network portion, only 16 bits network portion, right? But here we can see like /19. It clearly shows that already network has been subnetted 19, right? So now based on this, just figure out like which answer should be correct.
The answer is F.
Okay, so you said like answer number F means like 8 subnets and 8190 host per subnet. Okay, so yes, 8 subnet is correct, and this one we need to perform computation to verify that. And why 8 subnets? So let me explain first portion of the question, because here like we can see /19, default is /16. So definitely 3 bits must have been borrowed, right? 3 bits must have been borrowed from the host portion. So just we can find out that, and 3 bits means 2 raised to the power 3 subnets, that is 8 subnets. So there is no doubt about that. Number of subnets would be definitely 8. There is no question about that, right? Now the question here is, in three options D, E, F. They all have 8 subnets, 8 subnets, 8 subnets. So now we need to find out number of hosts per subnet. So if I write down this subnet mask in binary representation like 336 to 8, 336 to 8, 16, and then 39 and 1, 2, 3, 4, 5, and then again 1, 2, 3, 4, 5, 6, 7, 8. Now, in order to find out number of hosts per subnet, count
Yeah.
number of zeros, right?
Mhm.
And how many zeros? 13.
13.
So to compute this, 2 raised to the power 13 and subtract 2, right? So if it comes like 8190, so yes, definitely answer is correct, 8190. But we need to find out 2 raised to the power 13. So if you are unable to perform that computation, so as I said in the beginning, like day before yesterday, that you can use calculator then if you don't remember, even like uh, this way also you can understand like already we know like 8 bits means like 2 to the power 8 means 256, 2 to the power 9 means like 512, 10 means 1024, 11 means 2048, 12 means 4096, and 13 means 8192, right? So no need to use any computer because just keep on multiplying 2. In fact, if the number is exponentially increasing 8, 9, 10, 11, 12, so just multiply the value with 2 only. 256 into 2, 512 into 2. This way, like you can keep on doing computation. So yes, answer is very much correct. Like right answer is F, 8 subnets and 8190 hosts, because 2 raised to the power 13 is equal to 8192 and minus 2. So that's correct. But still, if you have to find out like from here by using calculator, so you can go to scientific calculator, and here you have x raised to the power y, so 2 and raised to the power y, and let's say 13, and then look at this number. So the number is 818192. So what I did, 2 raised to the power 13. And how we do, so first click here 2 and then this number x raised to the power y and then the power value. So that's another way, like if you get confused then you can use calculator for doing computation. But yes, answer is correct, 8 subnets and 8190 hosts per subnet. Now here, like the question is again a tricky one, or what? You need to configure a server that is on the subnet this. The router means the gateway has the first available host address. Already first IP address is already in use. Which of the following should you assign to the server? Got the question? Or should I explain this question? Because first you'll have to understand question very well, right? Then only you'd be in a position to answer the question.
So I have a question in here.
Yeah, sure.
If the router has the first available host, I can assign the server the second, right, or third, whatever.
Second or maybe third or maybe fourth. Yes. So let us assume that you have computed a range of IP maybe from .1 to, hypothetically I'm taking, let's say you have computed that IP can be anything from 1 to 62. So for example, in any subnet, like a range of IP, like valid IPs 1 to 62, and in the question it's saying like the first IP is already in use, means first IP has been already assigned to the gateway, to the router, means still we are free to assign any address from .2 to 62. From the same range, we can assign any IP address to the server, to the laptop, to the tablet, anywhere. So yes, exactly the same question is here. From the range of valid IP, first IP is not available because already assigned to the router, but yes, other IP you can assign. Now do your computation again. I'm giving you a couple of minutes.
Okay.
So think like what should be. This one is again a tricky one. So you'll have to do computation. So rather I would give you 5 minutes. So take 5 minutes and try to answer this question after taking 5 minutes. So have you done like your calculation?
Yeah, I have done it and
Okay.
the answer, but you can.
Okay, sure. I will verify your answer. So first, like, what you think, like, which option should be the appropriate?
C.
Okay, so you said option number C means the IP address would be 26, and then mask should be 255.248. Okay, so mask, yes, is correct because /29 is very straightforward computation, means 29 ones. So we can write down this way 33628, 33628, 33628, 24, and then 5, and then 3 zeros, right? So this way 24 and 5, 29. So this computation is very straightforward, like 255, 255, 255, and this is 248. So that's correct. 248 is correct. But since here again in 248, like there are two options, so we need to find out IP address. So in order to compute IP, so we will have to do computation
The power of
like
5.
exactly 2 no, 2, yes, number of subnets would be 2 raised power 5, so 32 subnets. And for block size 256 minus 248, so block size is 8, and 8 means like here your first subnet address will be 192.168.19.0. Then the next address will be this way 8, right? So this way we'll have to move, then the 16, and then 24. The next one will be 32. So in this range, if I take this one, /24, so in /24 subnet address range, IP address is 25 to 30, right? 31 is your broadcast address. 25 is already assigned. So we can assign any IP address like 26, 27, 28, 29, or 30. So the only option here is like this one 26, and the next IP I can see here is 31. So this is not valid because 31 is broadcast address. And other options already ruled out because mask not 248. So first we zeroed down like these two options because rest option other three options cancel. But since this IP address 31 is the broadcast address, the last address not valid. So answer is yes, correct. Answer is C. C is the correct answer. All right. So now we have moved to the last question of this assignment. And the last question is, you have an interface on the router with the IP this. What is the broadcast address of the host will use on this client? So a clue is given here. Clue is given that a device, network device, because router don't like router is just like any host device, end device, in fact, not more than that, right? So if IP address, let's say here there is a switch, maybe computers, here is the router. So here, this interface assigned IP address, this one, 192.168.192.192.10/29. So one of the IP address is assigned to this end device router. Other IPs, yes, can be assigned to other end host devices. But the question here is, what would be the last address of the subnet, right? And even this 10 is not the subnet address. 10 is like one of the IP address of the subnet. So first we'll have to do the computation, keeping in mind that the mask is /29. So looking at the mask value, CIDR number, this value, we would have to perform computation like finding out subnet address, range of IPs, and broadcast address. And this way, we would be able to find out broadcast address of a specific subnet from where this IP address would have been taken or would have been assigned to the router. So that's the question, in fact, the broadcast address, the last address of this subnet. And even this is not subnet address, it's also one of IP address of subnet. It's just an IP address. We don't have idea about the subnet address, but yes, we can calculate subnet address. So try this question also, whether you are able to answer or not.
The answer is A.
Which one? Option number?
A.
Option number A. Okay, so let me explain this. Like, so here, like IP address is given. So just forget about this. To answer this type of question, you can first like focus at the class of the IP. So it is class C address and the mask. So without subnetting, we understand class C means like /24. Here we can see like 29. So that means 5 bits
Five.
must have been borrowed, right? 5 bits must have been borrowed. And then after borrowing 5 bits, subnet mask would become 33628. 5 bits must have been borrowed. So this is the after doing subnetting, like borrowing 5 bits. Now this is equivalent of /29. So in decimal, we can write down again 248 and here 255.255. And then we will have to find out magic numbers. So again, the magic number block size is 8 because this number need to be subtracted from 256. It means if I have to write down subnet address, so the subnet address will be like this: 192.168.192.0, then 8, then 16, then 24, then 32, and so on. And now, if we find out range of IP address in any subnet, so in this subnet, range of IP address will be .12.6 and .7 broadcast address. Here .9 to .14 and .15 broadcast address, and in this subnet .17 to 22, 23 is broadcast address. So yes, we got the answer .15 because 10 IP address is from the same range. So if you look at the range here, so 9 to 14, 10 IP address from this range, and the last address is .15. So answer A is correct here. So this way we can perform computation. So not always like we are asked to do subnetting in the same way, like that network is given and divide into n number of subnets. So maybe a bit tricky in fact. So after doing practice, if even you will become comfortable. So no matter like whether you are doing reverse computation, like you are calculating network address or subnet address from the IP address, or maybe a subnet address from the network address, from this slash value to the decimal subnet mask, or in reverse order. So you will become confident. It's just about doing practice. So I think it was the last question. Yes, and then answer is also written here, so you can match your answer. So we have almost done some like exercises based on subnetting, and I will share this PDF again so that you can go through all the questions one more time from question number 1 to question number 10. So I will share this PDF. And now I'm going to a little bit talk about router, because the next topic I'll be starting router. But today session, I will keep a session today, short session in fact, so not very lengthy session today. So some like I have some appointment in fact today, so I will keep today's session a bit short. And the next topic, like so far we have understood a basic of networking of LAN WAN. So if I summarize like what we have finished so far, So we started with networking basics, fundamentals like LAN or wide area network, about your network interface card, a little bit about protocols, right? So we finished doing all this. Then we started IP addressing, class ABC, and then finally subnetting. And in between, I just very high level overview. I just gave like about a gateway concept. In fact, default gateway, right? So only like these three main topics we have covered so far. So I hope you all are now confident or like familiar with all these three. I mean, like networking basics, fundamentals, IP addressing, and subnetting. And the next topic would be, of course, like giving some basic knowledge of command line interface of Cisco router, command line interface of Cisco router, because Cisco router has different operating system, technically known as inter-network operating system, IOS. As like we understand, like on computers, if we run Windows 10, so Windows 10 is an operating system. If you are running Mac or you are running Linux or any other like Linux flavor, it's all different operating system. Similarly, routers, Cisco routers mainly, I'm talking about Cisco router, because Cisco is one of the leading vendor company. So Cisco routers and other network devices, not all, but routers and some switches, they run like this iOS, inter-network operating system. Operating system is different than Windows, Linux. So in order to get familiar with Cisco operating system, inter-network operating system, yes, like we will have to get into CLI mode of configuration and all that stuff. And then only I can go to the main topic. And the main topic is what? Routing. So routing is the main topic, right? But directly I cannot jump to IP routing, because in IP routing is something what? IP routing is like communicating different networks or subnets, right? Because so far what we have discussed that if we have assigned IP address from different network class, from different subnet, then devices do not communicate with each other. No matter whether all devices connected to the same switch in the same location, in different location, no matter if IPs are not from the same network, not from the same subnet, they will not communicate, right? And here comes the routing concept. Routing. And but before I jump to routing even, another important point I must mention here. If like at first place, we are doing network segmentation, I mean like we are like using, let's say here, location A, maybe US East region or network switch, and computers, one computer, two machine, three computers, four computers, right? And there is another network here, different network at different location in different region, maybe in different city or country, no matter. So at first place, what intensely we are designing different network. I mean, like we are assigning IP address, let's say here 10.0.0.1, 10.0.0.2, 10.0.0.3, and 10.0.0.4. And here maybe different IP, right? Remote location, different IP. Here, let's say 172.16.0.1, 172.16.0.2, 172.16.0.3, and 4. And let us assume that somehow, with the help of service provider, these two locations, A and B, we have managed connecting both switches right? With optical fiber cable, any cable, I'm not talking about router, there's still no communication. Host device 10001 can communicate with 10.0.0.2, 3, 4. Yes, will communicate definitely for sure. But 10.0.0.1 will never communicate with 172.16.0.1. It's not because of physical connectivity, because physical connectivity, yes, like they all are connected with each other. Both switches are connected, right? But since IP address is from different network class, a different network, a different subnet, so they will not communicate. So question here is why we don't assign IP address from the same network? I mean, like, why to assign IP address 172.16.0.1.0.2.0.3.0.4? Why not to do this way? Like, why not to assign like IP like 10.0.0.5, 10.0.0.6, 10.0.0.7, 10.0.0.8? So this way, we don't have to understand routing and route and other stuff. Yes, we don't have to then, because now if there is proper connectivity, then 10.0.0.1 would definitely communicate with 10.0.0.5, even though both computers are in two different regions, in two different countries, in two different cities, they will communicate. But generally, we never do this, right? Why? Because if we do not do network segmentation means if we assign IP address from the same network, from the same subnet, then what would happen? If this computer generates any broadcast traffic, for example, broadcasts are unknown traffic, right? And there are a lot of broadcast traffic in the network. I will explain tomorrow about some of the important broadcast messages. Like one is like ARP, address resolution protocol, DSCP broadcast, a lot of broadcast messages. For example, let me give you a very high level overview. Let's say this computer one has no IP address, right? 10.0.0.1 has no IP address assigned statically because we have a server in our network known as DSCP server. What DSCP server does, DSCP server provides IP configuration automatically, IP address, subnet mask, and gateway, all the configuration automatically, right? So in large enterprise networks, generally we do that. Like we never do manual configuration because not scalable, not feasible. Like you cannot move across 5,000 or 10,000 computers to provide IP configuration. So what we do, we automate the whole process. We configure one of the device as a DSCP server, and we do all the configuration on server only. And this not necessarily DSCP has to be a server, can be your Wi-Fi router, can be another device, that is also possible. So DSCP server then provides entire IP configuration, maintain uniqueness of IP address, does everything in the local area network. But how does it work? So basically what happens when the computer machine booted up, you have powered on your machine, laptop or desktop, and as there is no IP configuration, and even this machine doesn't know like from where to get the IP configuration. So what it does, the moment it is powered on, you have like powered on the computer machine. So immediately what it does, it sends broadcast message, right? Broadcast message means a message to the server. Where is DSCP server? Can you provide me configuration? I don't know your identity because I don't have even IP address assigned to me, right? So without IP, even it directly cannot contact DSCP server. So what happens? This broadcast message means unknown message, not targeted message. So what this switch does then? Switch then forwards this message to all connected host devices, to this machine, to this machine, to this machine. Are you DSCP server? Are you DSCP server? Are you DSCP server? And also, if they all are in the same network, flat network, there is no network segmentation, this broadcast will hit another switch. And then here again, here, everywhere, flooding literally, right? And this is your WAN link, wide area network link, not the LAN segment. It's not free of cost, right? If data is just passing through this media, ISP will charge if like the bandwidth is metered bandwidth. Even in case of unmetered bandwidth, this media will get choked. Unnecessary will increase utilization. It is just one example of broadcast message. So in the LAN network, there are a lot of different types of broadcast messages. Generally, they are generated, right, periodically over a period of time. Whenever we first communicate with any device, I will take like 2 or 3 examples to explain this point. But at this point in time, you can understand a lot of broadcast messages, unknown messages, right? Generated. So if we design our network this way, a single flat network means like not using different IPs. So yes, communication wise, it is very good, but there is a flat network. A lot of broadcast messages will get generated, no hierarchy. Even the communication would become very, very slow. So what we do generally, we like do network segmentation. So instead of designing a single flat network, what we do, we use different IP network, different IP subnet. So this way, what will happen, and even we also do something like at switch level also, that is known as VLAN. I will explain that later on. VLAN, that is known as switch level segmentation or layer 2 segmentation. So that's something different. I will talk that also later on. Switch level segmentation or this what you call it VLAN concept. But for now, you can understand this way. If here IP address is 172.16, here 10.0.0.1. So first thing, just doing connectivity this way is not going to ensure communication between both networks. No, what we do, then we connect a gateway, a router here, a router, a network device, right? If I name it R1, here again, a router, and both switches are not connected, routers are connected each other. So what is the benefit then? Now, what would happen here? Broadcast message generated from this computer will definitely would reach switch, no idea, no knowledge. It's a broadcast message, unknown message, right? Not targeted message, no specific IP address, no specific MAC address or hardware address. So what switch does now? Again, switch will start flooding this message. Will send to this computer, to this computer, to this computer, even to router also. Router is also very much like a end host device, right? Now, router is very intelligent device. What it does? It behaves very differently than the switch. What it says, router says that if I do not know the destination address, if the destination address is, let's say, network broadcast or maybe 255.255 or last address of the same range, right? Just a minute. Okay, I think internet fluctuated. Now it's working. Okay. So if the broadcast address is like maybe 10.0.0.1 or 10.255.255.255 means the broadcast address, the last address. So what router does? A router does not forward those packets. No, never. Router will stop that broadcasting here only. Will say, okay, if destination is not known, so I will not forward the packet. Why? Because destination is if this the network broadcast address, and network broadcast address is last IP address reserved, internally used by devices. Now, the question here is, what if I have packet destined to a server, maybe database server, SQL database, Active Directory, or any server, and server is here in this network. This is my server, right? And I have to reach, I have to connect with the server. So again, what router does now? Again, router sends, sorry, even I don't know 172.16 because network is remote network, not directly connected with me. I don't have any idea, right? So then what we do, we go one step ahead, we configure router, we tell the router that yes, if you have any packet for this network address, For this network address, if you have any packet coming from the LAN network and the destination is any IP address from 172.16, then please do not discard, send the packet to R2 over this link. But if you get a known packets like 255.255 or 10.255.255 means broadcast address, then yes, do the same treatment, don't forward them. So this is something, a very nice way of like doing communication. Now what router is doing now, after doing all this configuration, unknown packets, broadcast packet dropped, known packets, known means if the packet is destined to any IP address of the remote network, then will be forwarded. But by default, both will be treated in a same way. Even the packet destined for remote network B or broadcast packets, unknown packets, they all will be treated in the same way by router. So what we do as an administrator, we configure these two network devices. We tell the router that if you have packet for 172.16, then please do not drop. Here is the route the packet to the remote network. And that's what routing is, right? Routing. And again, we go to this router, R2. Again, we configure R2 router. We will have to tell R2 also that if you have packet for this network, and we mention the entire network address, right? Remember the first address reserved because of this reason. Because when we do routing, so we are not going to specify individual IPs, because this network may be very large network. Maybe in this network total there are 500 IPs. So I cannot put route for 500 IPs. No, what we do, we put route for entire subnet address, right? Subnet of 500 computers. The first address, remember we reserved first address because of this reason, first address, right? So we have reserved first and the last address, but we use like the first address in routing. We use that address, right? The first one. Last address, directly we never use that address, but internally that address is also used. Devices use the last address for broadcast purpose, for broadcast reason. So when we put routers, like the network UI is like acting as an entry and exit point. Remember, like yesterday, I mentioned this point that the gateway is entry and exit point of a network. Without a gateway, without a router, different networks can never communicate. But even different networks will not communicate just by putting a router. No, routers require configuration, routing configuration, because unknown packets, broadcast packets, they both are treated in same way, not forwarded, discarded. So what we do, we configure routers then in order to route traffic across different networks, right? So before just jumping to this routing configuration or the routing concepts, we will have to understand some basic commands, basic command of routers first, and then we can talk about routing. And another important point here I must mention, like I took example of two networks only. I took example of two networks. What, like if your organization, your company has maybe 20, 30 different locations, one network here, location A, location B is another network, location C, location D, location E, location F, different network, different locations. You have routers everywhere. One router here, entry and exit point for this network, one router here for this network, a router here, a router here, a router here. And let us assume they all are also connected with each other with the service provider, ISP, maybe this way when they all are connected. Now the question is, if I have to send packet to network F here, right? Maybe in somewhere in US West region, I'm putting up in US East region. From here, I have to communicate with the server in this network. Packet will hit the router here, R1. Now R1 will have to have route for network F, right? Because if the destination network is not known, let us assume this network address is 10.0.0.0/8. So if R1 doesn't have information about this network, so what will happen? Discard it here. R1 will immediately say, sorry, destination, I no idea. I don't know like how to get the packet to the destination. I cannot forward the packet, right? So first thing here, we as an administrator will have to put this routing information, network information here in router 1 configuration. We have to put this route in a table. Technically, the table is known as routing table. And then again, another important point here to understand that in order to reach 10 network, there are multiple routes now. Which path should be chosen? Whether R1 should first send packet to this network, then this network, and then this network, or taking different path, going first here, then here, then here, and then here, or going this way. So you can see like there are multiple paths here. Which is the best path, shortest path, which will take less time? So that again, we have to tell the router that the remote network is this, and if you have any packet, then just route this, take this path, right? Shortest path. But you understand, like in very large enterprise network, literally this becomes very difficult, in fact, because let us assume that you like mention here in network side A that take this blue path, for example. And because of any reason, if this link is unavailable, link goes down. So again, you'll have to modify configuration manually, not feasible, right? Still, there are a lot of alternate routes to reach the network, but automatically information will not be changed. Plus, if you have total 50 subnets or 50 different networks, so just configuring routers manually would be very, very difficult task, right? So in routing, there is another concept known as dynamic routing. Dynamic routing, again, we will have to study, understand some protocols. So what we do then, we just configure protocol, routing protocol, like one of the popular protocol, and that is part of your course curriculum also. So we will understand that, and the protocol name is like OSPF is one of the protocol, open shortest path first. So what this protocol does, it automatically computes the best path to reach the destination, right? Based on the bandwidth, the data transfer rate. And if something goes wrong with any link, immediately route gets changed. Immediately, protocol informs the router that, hey, like this path is not available, take alternate path, right? Even we don't have to put route manually. So in CCNA, we will understand both. Like manual configuration, first I will start with this static routing, doing manual configuration, and then I will move to the dynamic routing. Like one of the most protocol is OSPF. There are some other protocols also, but this one is the most common protocols. ISIS, BGP, RIP, and OSPF, they all are different routing protocols. So we have both like static, dynamic, but the point here is first we will have to understand basic configuration of router. Basic configuration of router. Directly, I cannot jump to the router. In fact, basic, I mean like here, if I take a router, this is a router and it's a symbol, a standard symbol. And if you double click this device, so you get to know like the look. And here, if I zoom in, so the router looks like this. This is the device. There are different ports here. This like simulation. So there are different here slots. Like we put some like cards here also if required. Otherwise, you can see like there are different ports and here off on switch, and here there is specific model. This one is like Cisco 2900 series. So different models, different configurations. So it's a look wise, in fact. And maybe if I pick another one, so this one is a very simple 1841, a very small router. And if I zoom in, so this is another router. So this one is like off on switch, and there are some ports here, fast 010/0 console, auxiliary. I'll explain like these different, and there are some free slots. In fact, we can insert like some modules for additional connectivity. So this is the physical view, in fact, and but whenever we power on the device, so like uh, and we use some software, and I will show you like the software and program everything. But it's like the operating system is like this. This is operating system, right? Operating system means iOS, inter-network operating system. So you need to be first familiar with iOS commands, Cisco iOS commands, because configuration is done from CLI. Not very tough, it's very simple, very easy. Believe me, just after 1 or 2 sessions, you will become very much comfortable with the command line interface. Very, very easy, right? Simple commands, in fact, because like we get like just we can use tab key from the keyboard to just have the information about anything. Routing table, like the table I was talking about, show IP route is the command. So what I did, I just entered tab key from my keyboard. Simply I can say show and then IE and then question mark. So you can see like there are 3 commands available with IE. So now let's say I type here IP. Still, I don't know, like I don't remember the next command syntax. So you can use question mark here. So it output displays like here are like different options. So now I remember, okay, I need to run this command. So now again, just type RO, for example, tab, and then command is completed. So this way, like, and even like if let's say I have to assign IP address to here for this interface. If I'm doing anything wrong here, let's say I just say IP address, just giving you an idea. And what I did intensely, I committed a mistake. And here there has to be space between IP and address, right? It's just a command, but there has to be a space. Like the command is like IP and then address. What I did, I didn't give any space here, and let's see what error message we get here. So clearly, like the error message is showing here, invalid input detected at and apostrophe, the symbol marker, and marker is here, just like below A, right? So we understand like here there is a problem with the syntax. Again, let's say I do another mistake here. Let's say now this time I typed IP address and then 10.0.0.1, right? I forget to mention subnet mask. And see here, what it is saying? That command is incomplete. Now let us assume that I don't know like why the command is incomplete. I don't know the next syntax. So what I can do, I can put a question mark, right? What I did, question mark. So it's telling me like you would have to specify mask in this format. Now if I put the subnet mask, let's say I'm putting subnet mask absurd. I mean like the value that is not possible, never possible, right? This is invalid subnet mask. Because you understand whenever you do binary to decimal computation, so subnet mask value would be either 192 or 224 or maybe 240 also possible, 248 possible, 252, maybe 254, 255, like all possible. But 130, no, never, right? Because all ones and then zeros, so consecutive ones and then consecutive zeros. So and you know like how to do the conversion from binary to decimal, 128, 64, 32, 16, 8, 4, 2, 1. So take any numbers, add them. Never you will get 130, right? So even iOS is very intelligent. It understands like the mask is something absurd, bad. Subnet mask is what? Bad, not correct. And let's see what error message it gives here. And it says like bad mask and some hexadecimal value for this IP address. So my point is, even though Cisco router, we have like some graphical way also to configure the router, but most of the Cisco engineers, network engineers, still they prefer to use CLI. because in CLI we have a lot of flexibility, easy way of doing configuration. Cisco came with some, like graphical tool software for doing configuration from graphical user interface mode. I have never seen people using GUI mode in production environment for router configuration at least. For firewall configuration, yes, GUI mode is used. For router, no. CLI mode. CLI mode. So even though like we have GUI mode, but yes, a lot of limitations are there. We don't get maximum flexibility in GUI mode. So still we prefer to configure routers from CLI. So that's the reason like you will have to understand command syntax, the command that I'm using here, right? You need to be familiar with basic commands first, because if you look at the options, the prompt like is getting changed somewhere here, like config if I say end command, then I'm back to another mode here. If I say disable, then I'm here. And in this mode, like I cannot run some commands. So if I say delete something, no, it's translating or something, like because the like even there are different modes here, right? And you can see like different prompts, pound symbol, greater than, right? So in next question or next class, I'm sorry, I'll explain first CLI commands, like all about hardware appliance first. What are different ports used for? So first you need to understand different ports, cabling, right? From physical perspective. Then I will take you to the CLI of the device, command line. And side by side, I will also explain how do we like start doing configuration in real environment, in production environment, because I have like a good amount of experience working as a consultant also. And still I have taken like a couple of projects. I'm working as a consultant also, network and security consultant. So apart from teaching, I do take like small projects like related with networking, security, cloud, cyber security. So even I will uh, explain that also, like how we do in real environment, because it's a simulator, right? So there are some differences between physical real environment and simulator. So I will try to bring out those differences also, so that you can understand the difference or differences, right? But first I will start with a physical architecture, internal components of this device, ports, connectivity. I will compare like virtualize and the real environment, real network environment, and then I will take you to the CLI mode of it. And I will start from the scratch, first like basic commands. And once you would become familiar with commands, right? Basic commands at least, 8 to 10 commands, not more than that. But once you will get familiar with like basic commands, then I will start the main topic. And the main topic is IP routing. And you understand what we are going to learn in IP routing. In IP routing, we'll learn how to like make communication happen across different networks. So first we'll start with 2 networks, maybe 3 networks, 4 networks, 5 networks. We'll understand the whole routing concept. Once we have finished IP routing, then again we'll be back to the LAN segment switch. That okay, like here, like we have 500 computers, location B, 500 computers, different network router, but can we do micro label segmentation in the LAN itself from the switch level? Yes, that is also possible. So we will understand that concept also in VLAN, virtual LAN segment. So step by step, like we will move. But first thing first, and the first would be like understanding routing, and then we'll understand switching part. So that's the way like how the class will proceed. And tomorrow, but I'm not going to today. I'm sorry, today I'm not going to start routing or routers or iOS commands. Tomorrow I will start. So I have something like a time issue today. So there is another class also schedule, and I have some personal work to do. So I'm just keeping your session today short. I hope you don't mind. And tomorrow we will start with First, like the intro of like Cisco routers, introduction of Cisco routers, then basic commands, physical connectivity, and we'll get time. Then I will start the basic of routing also. We'll see like if time will allow me, then definitely I will do that. And I will share this PDF like uh, your 10 questions like that we discussed here. And in iOS commands, as there is no theory, so what I will do is straight away I will be like covering like commands and other stuff like in theoretical way. So side by side we'll be doing and we'll be seeing also like, so that will be much more better. And then after tomorrow, you will get 3 or 4 days like off. In fact, so Thursday till Sunday, so in that time, you can do your like command practice and all that. You can install this simulator on your computer, like packet tracer, and then you can start doing lab practice at your own like. So because basic at least you understand IP address, subnet mask. So even still, if you have some confusion in subnetting, no problem. We'll come again like in routing section. So we can discuss further, no issue. Or whenever like you will ask any question based on subnetting, I won't mind like taking those questions. But at least if you understand basics like IP address, subnet mask, gateway concepts, so at least understanding routing wouldn't be very difficult. You can easily understand. But in routing also, this subnetting topic will come again, right? So at that time, again, I will explain like some key concepts of this TCP/IP because would be required in especially in dynamic routing section. So at that time, I will explain about like those concepts also. So all right, then I'm stopping recording here. So if you guys